Okay, today we're going to talk about heat energy or radiant energy. Now, you need to know the definition of heat. That is a form of energy caused by the internal motion of atoms. Somebody way back in the 18th century, Thomson, he was also known as Count Rumford, he proved the theory of heat being invisible, of it being a weightless fluid, and he concluded that heat was a form of energy. 40 years later, still way back in time, James P. Joule investigated the theory, and he said that motion produces heat. Anything in red, you need to have copied down. Okay, that's Count Rumford, that's Joule. Anything in yellow on the next few slides you need, this should just be a review for you. Conduction is a transfer of energy through matter by direct contact of particles. Conduction has a D, just like direct contact has a D. A conductor is a material in which heat passes through easily. Pretty much solids and metals are the best conductors. An insulator is a material that delays or inhibits movement of heat. Basically, an insulator does not let heat travel through it. So wood, plastic, like a straw, water, wool, air, glass, all of those are insulators. Convection is the transfer of energy when a large mass of liquid or gas, like a fluid, moves from one place to another. With convection, hot always rises, cool always sinks. Every single convection current, whether it's in the atmosphere, warm air is rising from the surface, goes to the upper atmosphere, cools and sinks down. That's what causes wind, by the way. Whether it's a refrigerator like this example, cold air near the top of the fridge. If you look in your fridge, you actually have a fan up there, okay, or condenser. The cold air comes from the top, sinks to the bottom, and all the warm air down here at the bottom rises up. And you have this convection current happening in the fridge or freezer. Radiation is a transfer of energy in the form of waves. Matter is not needed. So this is why radiation happens through space. Only radiant energy is absorbed and it changes into thermal energy. So if you think of the sun shining down on you, you'll see the sun shining down on, let's say, your arm. And then if you feel your arm, it's actually hot. That's the radiant energy changing or converting into thermal energy on your arm. Okay. Radiation can pass right through clear materials such as window glass, and it is reflected by shiny bright surfaces. I want you to draw this in your notebooks. These are very, very common pictures that you're going to see. With a fire, the warm air is rising. That's convection. Okay. If you're standing in front of a fire and you feel the heat coming towards you, okay, that's radiation. It's traveling through empty space, air. And if you use the fireplace poker, even if you toast marshmallows, you've probably seen this. Okay, the part of the fireplace poker or the marshmallow stick that goes into the flame is going to get really hot. Okay, that's direct contact when this part right here hits the flame or touches the flame. Okay, the next few slides, I think it's red that you need to copy. Temperature is a measure of the average kinetic energy of molecules. The faster the molecules move, the more kinetic energy it has. In the terms of temperature and heat, the faster the molecules are moving, okay, it's going to end up being a warmer temperature. You'll feel the heat. So adding heat speeds up atoms, causing more kinetic energy. A thermometer, you should know this, guys. A thermometer you use to measure temperature. In science class, we use Celsius, where 0 is freezing and 100 is boiling. At your house, or what you're going to see, like at the bank when you're driving by the bank and it shows the temperature, or car dealerships sometimes have them, you're going to see the Fahrenheit scale. This is the Americanized version, where 32 degrees is freezing and 212 is boiling. Now, scientists in the real world, scientists have to use something called the Kelvin scale, and that is to find the temperature for extreme temperatures, for finding out how hot the sun actually is. Okay, that would be an extreme temperature. To find the Kelvin, all you have to do is add 273 to the Celsius scale. Okay? And there's something called absolute zero. Okay, happens at 0 degrees Kelvin, and this is the point when every single atom stops moving. There's no molecular movement whatsoever. It's way, way colder than freezing. An ice cube in your freezer is not absolute zero. And I'll show you examples of this in class. Here are your temperature scales, skipping by it. Okay, heat is measured in units called calories. 1 calorie is the amount of heat needed to raise the temperature of 1 gram of water 1 degree Celsius. And we have something called specific heat. It is the ability of a substance to absorb heat energy. Every substance has a different specific heat, and we'll go over that in class also. Okay, you need this equation up here at the top. Okay, this is how you calculate heat energy. Okay, what this equation is showing you is either heat that's being gained or something's getting warmer, or heat that's being lost, something's getting colder. The formula is triangle. Triangle means change in temperature. Okay, mass times change in temperature times the specific heat. Okay, and we would give you the specific heat, such as this problem down here. Okay. It says how much heat would it take to raise the temperature of 4 grams of aluminum. The mass is 4 grams of aluminum. 0.22 is your specific heat from 0 degrees to 5 degrees Celsius. So our mass is 4. Change in temperature from 0 degrees to 5 degrees. Okay, your temperature increased 5. So 4 times 5 times the specific heat, which we gave you. It's right here. Times 0.22, and you should come out with 4.4 calories. We will do this in class. Don't even worry about this. Skip right through it. Okay, what I want you to do is in your notes, number your notes, just 1, 2, 3, 4, and put the definition. You have a word bank at the bottom. Put definition next to each of the defined words. Okay, so pause it and take a minute to do that. I'm going to check this in class. Okay, this is going to be numbers 5, 6, 7, 8, and 9. Okay. Once again, you're not given a word bank this time. I want to know how thermal energy is transferred, and we'll go over this in class. Remember, this was 5, 6, 7, 8, and 9. Okay, and we're going to stop here. Don't worry about this. We will get it at another time. See y'all tomorrow.